Hello and welcome to Cognito Key. Today, we're going to tune into the science behind why your favorite songs sound so incredibly crisp and clear on the radio. Yep, we're talking all about frequency modulation. I mean, have you ever really thought about it? You're driving, you switch from an AM news channel to an FM music station, and boom, the sound is just crystal clear. So what's the secret sauce? Well, it's not magic. It's actually some really clever engineering, and we're about to break down exactly how it all works. Okay, so to really get FM, we first have to talk about what came before it, right? And that was AM, or amplitude modulation. Now, AM was revolutionary for its time, but it had this one huge flaw. It was super sensitive to interference. Stuff like thunderstorms, power lines, even your blender could create that awful static and crackle. It became pretty obvious that for high-quality sound, we needed a better way. And that better way, that was frequency modulation, or FM. It was a totally different way of thinking about sending sound through the air, a way that just elegantly dodged all those noise issues that AM struggled with. So, let's really dive in and see what's happening under the hood. So, what is frequency modulation, really? Well, to put it simply, instead of messing with the power or the strength of the radio wave like AM does, FM changes its frequency. Just picture a wave going up and down. FM doesn't care how high that wave goes. Instead, it changes how fast it wiggles up and down. The power, the amplitude, stays the same. All that juicy audio information is cleverly hidden in the speed of that wiggle. I know that might sound a little abstract, so you know what? Let's break it down, step by step, and actually see how your favorite song gets, well, kind of stamped onto an FM signal. All right, step one. We start with our message signal. This is just the raw audio, the music, a person's voice, whatever sound we want to send out. This is the good stuff, the information itself. Next up, we need a ride for this message, something to carry it over long distances. And that's where the carrier wave comes in. Think of it as a blank canvas. It's just a simple, high-frequency, steady wave, basically waiting to be painted, or modulated, with our audio. Okay, and here is where the magic really happens. The whole system links the loudness of the sound to the speed of that carrier wave. So let's say there's a loud bass drum hit in the song. For that split second, the carrier wave starts wiggling super, super fast. And for a soft, quiet whisper, the wave slows right down. See? The power of the signal itself never changes, and that's the key to why it's so good at fighting off static. All the information is hiding in that changing rhythm. Now, there's a technical term for this change, and engineers call it frequency deviation. It's really just a way to measure how much the carrier's frequency shifts away from its normal resting speed. A louder sound, which has a higher voltage, creates a bigger shift, a larger frequency deviation. It's a really direct one-to-one relationship. So, how do engineers keep all of this under control? Well, they use a super important measurement called the modulation index. Now, don't get bogged down by the formula. The main thing to know is that this little number tells them how much space or bandwidth the signal is going to need on the radio spectrum. It's kind of like figuring out how wide of a lane you need on the highway for your car. A higher index means you need a wider lane, which, yeah, gives you better audio quality, but it also takes up more of that precious broadcast space. Okay, so we know FM gives us that amazing crystal clear sound, but is it the perfect solution for absolutely everything? Well, like with any great piece of tech, there are always trade-offs. So let's take a look at the good and the not so good. On the plus side, the advantages are pretty obvious. It's exactly why we love it for music. Because all that audio info is packed into the frequency, not the amplitude. FM signals are just naturally tough against noise. See, most interference, like static, messes with a wave's amplitude. FM just shrugs it off. And that's what gives us that amazing static-free sound quality that is just perfect for high-quality music broadcasting. But of course, there are downsides. For one, the gear for FM is a lot more complex and expensive to build. And maybe more importantly, FM uses really high-frequency signals that travel in straight lines. We're talking line of sight. They just shoot right out into space, straight through the Earth's ionosphere, instead of bouncing off it like the lower-frequency AM waves do. And that's the reason FM has a much shorter range. It's exactly why you lose your favorite local station when you go on a long road trip. But even with those distance limits, FM technology is still a huge part of our modern world. In fact, it's a cornerstone of so many communication systems. You probably come across it way more often than you even realize.
I mean, first and foremost, there's FM radio, obviously. But the same tech is also the backbone for the sound on your television. It's used in satellite communications, microwave links, and yeah, it even plays a part in how your cell phone talks to the tower. It really is one of those invisible technologies that's just quietly making our connected world work.
And this quote right here, it just sums it all up perfectly. The volume you hear, it's all determined by that shift in the carrier wave's frequency. So the next time you're cruising along, listening to music on an FM station, you'll know that every change in volume, every note, is all happening thanks to this tiny, subtle dance of a radio wave's frequency. So that kind of leaves us with a question to think about. FM was a massive leap forward in its day, right? It totally changed how we experience audio, forever. So what do you think is the modern day equivalent? What technology is out there right now that's fundamentally changing the way we all communicate and share information? Drop your thoughts in the comments below. We'd love to hear them. And that's our look at frequency modulation. Hey, if you found this explainer useful or even just a little bit interesting, do us a favor and hit that like button and maybe share it with a friend who'd get a kick out of it. And for more deep dives into the technology that shapes our world, make sure you're subscribed to Cognito Key. Thanks so much for watching.